Why, hello, everybody. Welcome to Atomcast. Today, I'm not going to be doing segments as I normally do because I have some wonderful guests with me today. We're going to be talking about space, the future of space, how we're going to get to the future of space, which is really I'm really interested in, and I'm really excited to hear about it. We're going to talk about Orbital Assembly, which is one of the businesses, and then, of course, we're going to get into space construction as well, which is, I mean, when you think about it, it's awfully important because that's the future. So, welcome to the show. We have John here and Jeff. Thanks for joining me today, gentlemen.
It's our
It's our
pleasure.
pleasure.
Yeah, definitely. Jeff, why don't you introduce yourself first and just tell us who you are?
Sure. Hi, everyone. My name is Jeff Greenblatt. I am the Chief Visionary Officer of Orbital Assembly Corporation, and I am helping to bring this dream into reality that we'll be telling you about later today. I've got a background in chemistry, and I'm a professional scientist. I do a lot of work in climate change research as well, but space is my second love, and for the last several years, I have been working more and more in that field as well. So looking forward to the conversation.
Excellent, excellent. And hello, John. Welcome.
Hello, everyone. My name is John Blincow. I am CEO of Orbital Assembly, the first large-scale space construction company. We started this a couple of years ago. It's an off-branch of the Gateway Foundation, whose intention is to build spaceports. Prior to this, I was a 747 pilot, flying all around the world in big jets. And one day I realized nobody's going to do this if we don't do it. So we started doing it.
That's great. And I mean, I fully believe it. I feel like that someone had to do it. You know, someone had to get that ball rolling. And I don't know if you've heard of Liftport, but I had Michael Lane, and he brought on some experts that he works with, talking about what he's trying to do, which is a lunar lift system that kind of uses the Lagrange point with kind of a, I don't know, it's like a ferry system, I guess, to go to the surface of the moon and back. And I was talking to him, and now that I think about it, it's like they might actually hire your company if of course they go through with making the lunar lift system that they're trying to do, because I haven't heard of, and not any time through that conversation, and they actually joined me in 3 different shows. Was there really a conversation on how to build this stuff?
We get that all the time, Adam. A lot of people come to us. Recently, we've had a lot of interest in space power because that's getting ready to move forward. A couple of companies want us to build structures to support their platforms. But we're starting to get a lot of other people too. Space elevator people want to talk to us because all of this requires space construction, the ability to put together large structures in low Earth orbit. So we're getting busier and we're getting more and more noticed, and also, which is a good thing, our investors are noticing us. So we're getting the money that we need to build these space construction tools and machines, which we'll talk about later.
Yep, it's the beginning.
Yes.
So let's talk about Orbital Assembly. This is it feels like it's the umbrella term for all the different things that you guys are working on. Is that accurate?
It's the umbrella company that's going to build everything that we need. Yes.
Okay.
Like the parent company is Gateway Foundation, and that it wants to build very large structures. But of course, we realize you can't build anything unless you have a space construction company. So the team from Gateway moved in this direction to form Orbital Assembly. And that's when we started developing space construction tools and machines to get that done. Yeah.
So here this is the Orbital Assembly website, and it kind of shows you many of the things that you guys are working on. The space hotel, of course, is really cool, and you named it Voyager, which now that I know that your favorite Star Trek is Voyager, I kind of was that why? Did you name it?
No, actually, that was Dr. Spilker's. He's our chief architect. That's his wife's idea. She's a JPL scientist who's been working on Cassini. And years ago, she suggested Voyager Station. And we were looking at other names at the time and so forth. But recently we decided, that's a great name because Voyager did so much for all of humankind. It's the first craft that has gone beyond our solar system.
Interstellar.
So,
yep.
Yeah. So that was the name we went with on Voyager.
That's cool. I really like that. So tell us what is Voyager? I have I'll pull up the picture while you're talking about it.
Sure. As big as Voyager is, it is a stepping stone for us. And we have a lot of stepping stones before Voyager, and maybe even a few after Voyager before we get to building spaceports. Voyager Station is, as you can see here, it's a conglomeration of modules. And these modules are not the size of modules they see at the International Space Station. They are enormous. They are 12 meters wide and they are 20 meters long. Wow. And they're not crowded in with a lot of life support systems, because that's all done in one module, which is called air, water, and power. These are modules mostly for habitation, or they could be laboratories, or they could be like one is just a restaurant, a kitchen, and a bar, which is called KRB. So this mixture of modules going around all around the station is going to have a collection of different entities. So we're going to see JAXA with their module over here. We're going to see ESA with their module over there. There may be billionaires who want to have the first property that you can own in space. They may have a module there. But we're expecting a lot of corporations. We've had talks with Virgin before about we basically state, we think you're going to get here when you're ready, and you're going to want to buy a module from us. We think SpaceX is going to want to have a module too, because when they bring their big craft up in space, the Starship, they're probably going to want to do crew training, and they're going to want to be based up in space where they can move around without having to go through atmospheric reentry every time just to recrew. So we expect them to show up also. There's a lot of entities that are going to be moving in here, and also countries that haven't previously had very large national space agencies. Brazil, South Korea. There's going to be a lot of people in this. It's going to be a fun place to go, because you're going to have a lot of the world there.
Yeah, our image is really an international community, and it would be a mixture of tourists and scientists, as well as commercial people testing new technologies. And I don't know if we mentioned so far, so this structure, if you bring up the image that we were just looking at, so it rotates, but it doesn't rotate at a rate that gives us full Earth gravity. It rotates more slowly. So we're designing this for lunar level gravity, which is about 1/6 what we experience on the surface of the Earth.
Okay.
And
still pretty good though.
Oh yeah, no, it's still plenty of gravity to keep your feet on the floor and your food in place, which is part of the the design for comfort that we're looking for, that makes this different from any other space station, because it isn't in 0G, although you can have microgravity if you want it. But what this does is it allows people to have a comfortable experience, and it's also a research facility, because we have precious little information on what both bodies as well as machines and other organisms are like at fractional gravity levels. And so we think that a large part of this could actually be used for doing research in what would ultimately be a spacecraft, say, bound for the moon or Mars, but able to be tested here in a low Earth orbit, which is a lot more accessible.
We really... Go ahead, John, please.
Oh, sorry. I didn't mean to step on you. Go ahead.
It's okay. No, well, I was just going to say, because we really don't have a lot of research on prolonged space flight on human beings, like what it does to our bodies. I know that fluid will gather in your brain, and your eyes will. I guess they have issues with the eyes, and even your bones. Like everything kind of stretches out, because we're used to gravity. We have 1G. It's 1G for a reason, because that's what Earth's gravity is. So, this would be a great place to really, it's right there.
You must have been reading my mind, because that's exactly what I was going to talk about. I was going to talk about how NASA has realized, as they're putting people in space for longer and longer periods of time, that it's just not working out very well. You've probably seen the picture of astronauts up there. They have this thing called moon face, where their head, it just gets all this blood up there. And what it does is it squishes their eyeballs from round into oblique spheroids, and they get nearsighted or blurry vision. And you don't want an astronaut not be able to see his controls, especially when he needs to be able to see what he's doing. So it's a very dangerous situation. That is just the early term stuff. Then, as you pointed out, you have bone loss and you have other things. And recently they found some very serious stuff where astronauts, they did a study of 11 astronauts, and 7 out of 11 of them were getting blood clots because they're getting stagnation of blood flow in their neck. And it was funny, because when the article came out talking about this could cause blood clots, like 2 weeks later, all of a sudden NASA announced, well, guess what? One of our astronauts got a blood clot, and we had to start giving him blood thinners to keep him alive, basically, until a cargo ship got there with more blood thinners to keep him alive until they got him back down. So this is getting very serious. I mean, we're talking about high stakes poker here now, when people go up there, for long periods of time. Now, this particular astronaut wasn't there very long, only there just a few months. But the longer you're there, the more serious these health problems get. If any of you have a chance, read Scott Kelly's book, Endurance. The first chapter is horrifying. He talks about what he goes through when he comes back down from Earth. He gets home, he has dinner with his family, and he decides he's feeling sick, so he goes to bed. And then he wants to go to the bathroom. He gets up and he looks down at his legs, and they're like big, giant water balloons because all the fluids in his body have drained down to his legs. And his girlfriend came in, and she's saying, "I can't feel your ankle bones." And he knew he couldn't call the hospital because they wouldn't know what to do. So it was just this kind of nightmare that went through. And he says something in his book, and it's a great book. He says, "I imagine that my my Russian counterpart is going through the same thing right now." And I think he's hinting that this is more widespread than just him, which of course the later studies show.
Yeah, it's interesting. Wow. And he was there for almost a year, I think 340 days or something like that.
Exactly.
It was actually a study because he has a twin brother, Mark Kelly. And so the idea was that and I guess they did do this, right? They looked at DNA, and they looked at a number of physiological measurements before, during, and after in order to see what spaceflight does to the human body. I don't remember the details, but it was quite revealing.
Yes.
Yeah, they actually did a documentary on Netflix about that, and I watched it, and it's half of the documentary is more about the family side of it, and I was just kind of waiting to hear more about the actual stuff. I guess he gained like an inch and a half because his whole spine stretched out.
Which sounds kind of nice, except for all the other effects.
Except for when he was saying that it was recollapsing, he said that was rather painful. I'm sure that was right when his ankles were water balloons.
Yes.
So do you think that the 0.6, or was it 0.6 gravity?
Yeah.
0.6 gravity. I mean, do you think it's going to solve
or
at least alleviate that?
It's actually 1/6 of a G. So it's 0.17 gravity, which is what lunar G is. But we're really excited about building Voyager Station because this is going to give all these space agencies the first time to do studies in artificial gravity to make sure that these things can be alleviated at a certain gravitational level. And if it doesn't work at lunar gravity, we can spin a little faster and bring up to Mars gravity. And maybe
that was my next question.
Yeah, so it's an opportunity to see what works, what's going to keep our bodies together for these long journeys, because we know they're coming. NASA, well, humankind in general, is going to be going to planets further and further out. First Mars, then the Belt, and then the icy moons around Jupiter and Saturn.
Mm-hmm. Yep,
it's coming.
Yeah,
I think. Do you think we'll be able to hit 1G?
Do you think? Go ahead.
Say it again.
We're not aiming for 1G. We're because we have that down here. We know that our bodies do well 1G. We want to see what is the lowest level really that people's bodies stay together. Because when you shoot for those higher G numbers, you're either talking about faster rotation or much larger shifts. So there's trade-offs to be made there. So we want to know what we can do with lower G levels.
Okay.
Yeah, lower G saves cost and weight because the engineering materials don't have to be as strong. But the other thing is, since John's talking about visiting other places in the solar system, Earth has one of the highest gravity levels of any solid body. If you look at all the other planets and moons, excepting the gas giants, Jupiter, Saturn, etc., they're all at a fraction of a G. Venus is the only one that's close to Earth. It's about 0.9. And everything else is at Mars level, which is about 40% of Earth's gravity or lower. So if we're going to be spending any time on these planets down the line, we're going to need to know that we can adapt and thrive in fractional gravity.
Yeah. Now, is this station going to be, flying around the Earth like the International Space Station, or is it going to sit in? Is it geosynchronous orbit? I think that's what it's called, where it just kind of stays in one spot around the globe.
We're going to be in low Earth orbit. Yeah. We're looking for a polar orbit. We want to have constant sunlight because we want temperatures to remain the same. We're not looking for large fluctuations there. And we also want the power too. We've been nicknaming it the power belt because we see a lot of industry growing around Voyager Station to take advantage of all that free power. And of course, the lessening effects of temperature variations too that ISS has to endure.
That's interesting.
But that is for the first Voyager station and the first project. I mean, it is our intention eventually to be able to build these things wherever we need to have a human presence. So there's no reason why we couldn't build them further out in one of these stationary points that you're talking about, geosynchronous or a Lagrange point, which is kind of a hovering point between, say, the Earth and the Moon, or other places further out. I mean, once the technology for providing artificial gravity, is refined and gets down to a cost-effective level, then we'd like to see that this would be used in many places, so that humans don't have to be in zero G unless it's of necessity for technical reasons or manufacturing reasons.
So that just sent a little trigger buzzing in my brain. I hear artificial gravity, and I think, is that even a possibility? Are we just talking about the spinning itself or the manipulation of gravity? Because I truly do think when we figure that out, then we're going to be able to travel the stars. That's when.
Yeah, the idea of having gravity plates like you find on Star Trek, one of my favorite shows, is that's a long ways off.
Is it?
Yes, it is.
Yeah.
Rotation for artificial gravity is the future, as we like to say. The future is rotation. That's what we need to focus on right now, because that's what we can do. When you talk about building gravity plates or something like this, nobody even has the faintest idea of how to do something like that.
True. Yeah, that's undiscovered physics, unfortunately. But rotation is easy. Rotation's easy. I mean, one day that would be great. But having a donut-shaped spacecraft, we have a huge amount of room. These things can also be extended, so they're more like thick cylinders, and there's a tremendous amount of space for people to live and work. If you're thinking about long-term habitation, these things could be made, many hundreds of meters wide, and essentially a spinning city in the sky.
Nice. Yeah. No, so I see here. Let me just pull up your website again. On the different, things you got going on here, I see you have Asgardia. Now that is the future country? No, not country. It's just like a nationality. Like what?
It's a kingdom.
Yes, kingdom. Explain that. And obviously, you guys have some sort of connection with them since it's on your website.
We've contacted a few of them, but we have no formal agreements in place. We put that there for the diversity of the projects that we're looking at. They go for small things like some fuel depots in non-rotating ones, and the rotating ones that Jeff's been working on, all the way up to large-scale space settlements like Asgardia is. Asgardia is even bigger than a spaceport, and the Gateway Spaceport is one of our aims, but this is even bigger. It's to show, this is where we're going. We're going to be building countries, cities in space. And beyond that, it never really ends. It's like terrestrial construction down there. We keep building bigger and bigger things. It's going to be the same thing in space.
Yeah, that's cool. Yeah, so let's talk about the construction part, because that is the way we need that, or else none of this can happen. We can't build this the Voyager space hotel until we have an ability to build it. I mean, is it a reality already? Do you already have the technology to build these massive ships?
We have technology to build massive structures. What built is kind of up to them, up to our client. If it's a ship, we could do it. If it's a station like Voyager Station, we could do it. There's not much really, I don't think, that we couldn't do given enough time and money. As you were pointing out earlier, it's the tools that's going to make this all happen. And that's what we've been working on. There is a huge collection of tools, new tools. The tools right now that represent the state of the art of space construction are used by NASA. And that is the big arm, the Canada Arm 2, and the astronaut in his spacesuit. That's pretty much it. Now, there's an extension of the arm called Dexter, which MDA made, which is what they call the hand of the arm. Kind of sounds like something out of Game of Thrones. But it's really the manipulator that they can put on that big arm to do things with it. And it's actually a rather good robot, if you think of it in those terms. But we have our construction needs to extend far beyond building something like what NASA did with ISS. The focal point of space construction is going to be around a machine that we've been working on, and we're going to be trying out late December and January, called the STAR. This is a structural truss assembly robot. And
bring up the image of that, Adam, if you...
Is that this one here?
There it is. Yep.
This is like the innards of it, right?
Yeah, this is actually the D-Star, the demonstrator of it. And what you look at here, these boxes are magazines for loading structural elements into the center box, which is kind of reside in the back. And the side box on the left-hand side there, that's another magazine for what we call T-frames. So you have L-frames and T-frames coming together into this machine, the star, and it builds out a truss. And our goal, which we're confident we're going to meet, is 90 meters in 90 minutes. Wow. Which means if you want to build a very large structure, you can do it very quickly. The follow-on from the D-Star, which you just saw, is going to be the P-Star, the prototype. That's flight hardware. And we're hoping to launch that next year. Would be too ambitious, but probably the start of the following year, early first quarter of 2022. That is not going to be building a straight truss like the D-Star is. It's going to build a round truss. And there's another image we're going to bring up here, and that's called the gravity ring. This is one of our important stepping stones. The gravity ring is a circular truss ring where you can start spinning that and you can do research on artificial gravity. Do we have an image of that one, Jeff, that we could show them?
We do. Yeah, there we go.
There we go. The P-Star would build this simple round truss, and it would have ACS engines on it, attitude control, and spin-up, spin-down motors. And what we want to do here is, you can see at the bottom there's a platform. It's a little bit hard to see, but there's an astronaut on that platform in a suit, space suit. And on the across from him at the 12 o'clock position, there is a counterweight, which is exactly his weight. And with the spin up, spin down motors, you rotate this thing, and it's the first artificial gravity created in space on this kind of scale. They've had small little ones for rats to run around inside of ISS, and they've spun some spaceships before to generate a tiny bit. But this one is real artificial gravity. We're shooting for lunar gravity that astronaut is going to feel and actually walk around in at about 2 RPM. This is an important step. And this is something that we want to get NASA involved in, or other space agencies, ESA, JAXA, and maybe a conglomeration of them, to actually have a functioning artificial gravity tool for research. The program may expand beyond what you see. We may start hanging habitation modules from the 12 and 6 o'clock position. We may put solar panels on the outside, so it could be more of a long-term tool. But it's a very, very important tool for the pivot that we believe that NASA is going to do in the near future, from zero-G operations like they have right now at ISS to rotation.
That's interesting. Now, I was looking for this this video because in the background, this is the star actually creating the framework. I couldn't find the actual video of this by itself, but if you see in the background, this is the star, and this is the arm you were talking about. We got two of them.
Yes, this is an early form of the star, and it's actually depicting a more advanced version of the star. It is what we call the G cell. It's the gateway segment assembly line. It's building these segments, and you collect these segments as you see here to form a structure. And we're confident that segment construction is going to be involved for a lot of large structure construction. When you don't want to just roll out truss all the way, you actually want to see, like you see at the front here, this is what we call whole plate, which is a combination of a micrometeorite defense and insulation and some other things too. You might even have solar power generation on the outside. So what we're showing here is this is advanced space construction, and this is what we're shooting for. And it's really not a big technological leap. Everything you see here has either been done or could be done with only a few years of development.
Right. So what we're showing is kind of a logical sequence of steps. We start with just building a straight truss on the ground to demonstrate the technology, and then we build a space version of that and build this rotating truss structure. But it's still kind of a proof of technology readiness, and could be for research, as John was saying. But bit by bit, we're building up to the ability to eventually create something this size, which is a lot bigger than the Voyager station we were showing earlier. This would sort of be a second or third generation rotating structure.
That's amazing. So this is all exciting. This is the future. This is I talk about this a lot. I do feel like we are witnessing the beginning of space travel. Like we have everyone talks about the 60s and 70s, the space race and all that. Well, I guess it started in the late 50s, but for the most part, it's like the 60s and early 70s. And now we're witnessing this new, I mean, of course, Elon Musk is making strides. And then, the Artemis program, like we're going back to the moon. That's the plan. Of course, Occupy Mars is a thing now. Like it is becoming a reality that we're going to be able to be on another planet. Like that's going to happen in maybe the next 10 years. Like it could happen.
Yeah. Yeah.
I think it's quite certain.
It's incredible. Now, is this going to be used? Like, could you bring this to the surface of another planet, or this is specifically for like zero-G operations?
The structures you've seen are for zero-G operation. They will remain in orbit. They are space stations and spaceports. Okay. Vehicles that bring people down to the surface, especially going through a heavy atmosphere, are basically trans-atmospheric vehicles, rockets, shuttles, and so forth, things like that.
Starships.
The vehicles that we might be building in the future, well, we will be building in the future, are something that would not be trans-atmospheric vehicles. They may bring landers with them. But one of our projects down the line is to build a space dock. We want to build a structure where you can build large vehicles to explore the outer planets, one that will be out there for a long time, one that's going to employ multiple levels of radiation protection, not just using polypropylene, which is they use at ISS, but also you're going to have levels of ice, and you're going to have an electromagnetic system outside of that, which is being worked on right now. In fact, that's one that Jeff was working on. You could probably tell more about that, Jeff.
Oh, sure. Well, yeah. So electromagnetic fields to essentially repel these extremely fast charged particles that are coming both from the sun, but especially from what are called galactic cosmic rays, which are extremely high energy particles that I think ultimately arise from supernovae and maybe some other astrophysical phenomena, but they're basically energetic particles that just plow right through your body under normal circumstances, and they cause radiation damage and ultimately cancer and death if you're not shielded. So one way to block it is to just put essentially thick blocks of concrete or polypropylene, water ice, as John was saying. All of these have to be several meters thick in order to bring the radiation levels down comparable to what we see on the surface of the Earth. And the reason why radiation levels are so low on the Earth is, well, we have the huge bulk of the Earth below us, and we have 10 tons of atmosphere sitting above us, and that does this comparable job. Yeah. So, but there's another way of doing that, and that is to run what's called an artificial magnetosphere, which is essentially, it's an electrical current system that's arranged in a series of circles that generate magnetic fields, and the magnetic fields deflect these high energy particles. And if you have sufficient power, and that's one big thing, and the fields are cleverly arranged, you can actually create a void region inside the field that essentially deflects almost all of the charged particles, including these galactic cosmic rays. Wow. And so it's still at a research stage, but we would love to fly a prototype on one of our in-space structures eventually, and that could become standard space equipment down the line.
Wow. And you said we have 10 tons of atmosphere above us, but that's not even adding into the fact that Earth has its own natural magnetosphere that's basically plowing a path ahead of us. And then, of course, we talk about terraforming Mars, but Mars lost its magnetosphere, and there is talks about trying to reinvigorate it. I guess that the same kind of studies will go hand in hand. If we can create an artificial magnetosphere for any ship that's traveling around out in space, then we can build it. I mean, I don't know if we could do it on a planetary scale, but
people have looked at that. Yeah, people have actually, even for Mars, since you mentioned that. So one of the researchers who's also looking at artificial magnetospheres for ships have even considered an artificial magnetosphere for the entire planet Mars, and it would basically be this honking huge generator which would sit out at one of these Lagrange points, which is a stationary point basically between Mars and the sun. It's a couple million kilometers away from Mars toward the sun. And essentially it creates this big field, and the solar wind as it blows past it on its way to Mars would get deflected and essentially create this envelope around Mars. Now, I don't remember how much power is needed. It's probably gigawatt scale, but in a Star Trek world, I don't think that would be a problem. So maybe the Martians will have a nice, radiation-free surface they can traipse around in.
Well, that will protect them from the sun, not interstellar waves or
Well, that's a
from
good point.
supernova.
Yes. Perhaps it still wouldn't be strong enough to deflect from the supernova remnants.
Yeah.
And I think for that, so I'm not an expert on artificial magnetospheres, but all the accounts that I've read, whether you're on Mars, the moon, free space, if you don't have an artificial magnetosphere, you got to be basically living underground. And so,
Yeah.
all the Mars cities are buried several feet below the surface.
Yeah, that makes me think of Ad Astra. Have you guys seen that one? That movie?
Sure.
Yes.
Yes.
I really like that.
Pretty accurate.
Was it accurate? Did you guys, you guys are into space. How accurate was that? Seemed pretty accurate to me. Of course,
I think
I'm
a
not
lot of the
scientist,
aspects were pretty accurate. I can't recall the details right now, but yeah, there was nothing glaring. Well, of course, until they get to the outer planets and
right, of course.
That's when the sci-fi takes over.
Well, what brings it up is though they had all these radiation blasts coming from Uranus, and they couldn't figure it out. And the only bases that were out there that were fine and still functioning were, of course, the ones on Mars because they were buried deep and they didn't get affected the same.
That's right.
And it doesn't surprise me actually if they're going to build things underground because it's safe from meteorites. You don't have to build like a shield system. And then, of course, the natural radiation blockage that will probably happen there. There's a show called Mars that kind of balances. It's like 50% real, actual scientists, real like actual, astrophysicists and all that. Elon's in there, and then half in the future of people actually going to colonize Mars for the first time. And it's really interesting because they really try to nail the balance between scientific exploration and private enterprises going to mine Mars, so which kind of leads me into what I wanted to ask you guys. Like, is it going to be like you said, it's going to be the international community essentially, right? But how much is going to be government? How much is it going to be private? How much is it going to be, for the good of humanity or for the good of a corporation that has all the money,
Well, that's a question we have too. We don't know. We're going to put this out there. We imagine it's going to be a mixed use station, what I call a composite station with lots of different players in it. But that is not really our goal. Our goal is eventually to build, rotating hotels that'll be very lucrative, and not just one, a lot of them. Because we feel that, although there's going to be lots of laboratories in a mixed-use station, when you have more and more of the general public going into space, and not just a few thousand every month, but a few 100,000 every month, you start to build a real economies. And when these economies, when you have these groups of stations, and not just one or two, and multiple support stations around them, maintenance facilities, fuel depots, people growing food for them. When you have all of this start to go and it becomes self-supporting, it changes the dynamic completely to where it becomes something they can just keep going and keep growing and so forth without government input. That's our real goal.
Yeah.
Okay.
Because now you get class people going into space versus just rich people. And, you got that going on. It just never ends. We become a true spacefaring society then.
The way I think of it is enabling. So I have this term that I like to use because I think it's very appropriate for all the work we're engaged in. It's called enabling technologies. That you have one technology, let's say the low-cost rockets that we were talking about that SpaceX and others are trying to develop. Yep. And that then becomes, like a foundational layer on top of which we can now build a second layer of technology, like our orbital construction. It relies on low-cost launch in order to make the construction of space objects feasible. And so now you have the ability to put, hundreds of people at a time up into space in a comfortable, safe environment. And what does that enable? Well, besides having some tourists go and having a good time, it also enables a workforce to really consider living and working in space as a reality. And then that starts to enable a space-based, economy to form. And being able to construct large things in space, maybe using resources from the moon or asteroids, makes the construction of space structures that much cheaper as well, instead of hauling everything up from the deep gravity well of Earth. And so then that's a third layer that continues to build, and eventually we have what John's describing.
Yeah,
I think
when
that's
you
really important.
you create that marketplace in
Yep.
space for anything, and like Jeff was saying there, for the space miners to sell their wares. They go out and they dig up a bunch of iron and they dig up a bunch of nickel. What can they do with it unless there's a buyer in orbit? And that would be us. We would buy all the structural metals they could bring us, but we would also be building the processing facilities for those ores also, because they got to be processed, and they have to be put into ingots, and they have to be machines. All that stuff needs to be built. Well, a space construction industry that's well developed can start doing all of this stuff. And now you have a self-supporting economy. And so, you can have space miners who are going to get their paycheck every month, and not have them go out of business like we have recently, because they basically didn't have someone who would make an agreement and say, yeah, you bring us metal, you bring us water, we'll buy it. When an investor sees that kind of activity going on between companies that want to go into space, that's when they say, okay, this is really starting to move now. It's not just people going up there and coming back. It's people going up there and supporting themselves with other aspects of the space economy.
Yeah. And that's something that I feel we almost need right now, because people are purposeless. That there's a lack of drive to move forward into this new world that we are, what we're talking about is living in space and actually traveling and searching around. That's my first thought. But then my second thought is, are we even going to have these jobs because of automation? Is it just going to be a bunch of robots that we're going to be able to send out and do all this stuff? A lot of people say, like, why do we need to go to Mars when we could just send a robot there? Other than, like, we said that we did it, like we actually went to go to Mars. But there's that, like, balance. Is there going to be a huge economy for regular people?
Yeah, we've been sending robots to Mars for decades now, and it's amazing what they bring back, the imagery and the data of what it's composed of. But it's not as exciting as when we have someone go up there and put boots on the ground. True. Because now we live through them. When the first people went to the moon and stepped on the surface there, we kind of felt like we were there too, because we could see, in a way, ourselves there vicariously. And it's the same thing when the first people start going into space. When you start getting lots and lots of videos coming back of people having fun at Voyager Station, they're watching a concert, they're going to dinner at the restaurant here and so forth. They can see themselves going there. And when they hear about these raffles that we're going to be having to give away free tickets occasionally, they see a chance now. And this is that direction you're talking about that our country needs. We need a direction. We're a superpower that needs a super project that can give people hope of a bigger, better future. And then, of course, the immediate one is the jobs. Space jobs, just for making things down here, are very lucrative. It's a much better lifestyle. But the excitement to the young people about having a lifestyle in space, about going to these planets, going to the moon, going to Mars, building things in space, that's what gives a country true direction. It gives it purpose.
Yep.
And also, the excitement, the emotional appeal is definitely an important aspect of it. But, human brains and human hands and just kind of snap judgment is also super important too. I mean, I want to say robots are getting smarter every year, right? We talk about AI almost as though it is a household word now. But for people who study it, we've got a very long way to go before they're actually making human level decisions. And the space environment is a hard one. The probes that John was talking about that have been uncovering amazing scientific data on the surface of Mars, they actually operate very slowly. And a human explorer could probably do the entirety of a 2-year rover mission in a few days' time. So there's a lot more that humans can do in terms of exploration, and obviously in terms of troubleshooting, construction, and running something that's far away from the surface of the Earth. So I think there's going to be a continued role for people for a very long time. Plus, we want to be there. We're sort of explorers by nature, many of us, and so there's an excitement and a desire to go, even if the risks are fairly high. So we want to enable that possibility.
Yep, I agree. So I this picture here, I saw it and I was like, I need to know what this is. What is this? This is cool looking. Is it some sort of, solar array system?
Yes.
Or is that?
Yes, it is. It is cool. This is called SPS Alpha, which is a space-based solar power system and this is of immense size. This is, I don't remember the exact dimensions. This is not our image. This comes from a colleague of ours called John Mankins. The basic idea is that each of these mirrors are probably several hundred meters in diameter. They are they're solar reflectors, and they're essentially taking sunlight and then concentrating it somewhere near the bottom, maybe there, where the solar energy is converted to electricity and then to microwaves, which are depicted by those purple circles there. Yeah, and they're beamed down to the surface. So a plant this size would be several kilometers across, and it would be generating gigawatts of electricity 24 hours a day, 7 days a week. So it'd be continuous solar power from space, which at scale, we think would be at or below the cost of ground-based solar power today. This could really revolutionize our energy system on the surface of the planet, and could be an example of one of these early industries in space that actually can pay for itself. And the reason why it's in this stack is because space-based assembly is an important part of it. So we see our company as playing an important role with that.
So I see something like that, and then I think about space base, space hotel, spaceport, space solar arrays. Is there going to be a point where we just don't see stars anymore, and we just see, the solar array, and there's the hotel, and then there's Coca-Cola's advertising?
I hope that never happens, because looking at the stars, I think, is an inspiration for a lot of us to go into this field in the first place.
I agree.
I mean, you remember, space is a very large, it takes up a very large volume. So even if you have a lot of objects, notwithstanding the issues with Starlink right now, right, the hundreds of satellites that SpaceX has launched to provide a worldwide internet from space, and it's starting to create little reflected lights in the sky. But, a lot of those structures, like the image you just showed, would actually be sitting very far away. So it would be out in what's called geostationary orbit, which is about 6 times the distance or the diameter of the Earth. So it would be almost invisible. And even if there were hundreds of them, I think it would still be a very, very small pinprick. And of course, many of these habitats we're talking about would be even further out than that. So.
Now, this I also found was really interesting. The Goddard Space Flight Center, I actually remember seeing something along these lines, and it was talking about building a telescope outside of our solar system, right past the line of interstellar space. Now, I don't know if this is the same thing.
It's not.
It's not.
I know what you're talking about, putting a telescope at the gravitational lens point, I think.
Yes.
Is that what you refer? Okay.
I believe so. I don't exactly remember what the telescope was called, but it was very intriguing.
This is called LUVOIR. We can talk about the gravitational lens thing at the end, maybe. It's very cool. It allows us to image planets around other stars. But no, this is called LUVOIR, and it's actually a design that NASA is planning to build and launch in a few years' time.
Okay.
Now, the reason why it's here is that it's a very large structure, and darn, I don't remember the dimensions here, but they are several dozen, meters on a side. The only way this can get up into space right now is if it's folded up like an origami, crane into this incredibly compact form that can fit inside the narrow fairing of a rocket. But we would like to be able to build these things without having to do that in space from simple components, and that's why we have this in our portfolio. John, did you want to add anything about that?
No, you're doing great. Yeah, this is one of the big ones. The problem with the space telescopes, the reason they're not one of our near-term projects, is not the space construction. We can put everything together that you see rather quickly. It's the mirrors. No one's figured out how to make the mirrors quickly. You have to get special glass, pour it, you have to bake it for a long time, then you have to grind it for a long time, then you have to polish it for a long time. And it's just a long, long process making these mirrors. I talked with some people at Ball Aerospace. They made the mirrors for several large telescopes, and they were just like, this is going to take a long, long time to do something like this. So when you talk about a big telescope with a lot of mirrors, we can do the other part real quick. We can have it all ready to go, but you got to wait years for those mirrors to show up. Someone is going to figure out how to do that quickly, and that is going to someone who's going to revolutionize space telescopes.
Right. I was just going to add, a lot of the advantage, though, is just being able to reduce the amount of mass that you have to launch And so and I don't know how much the mirrors weigh as a percentage of the total telescope, but let's say that they're only 10% of it. Well, if we can do the other 90% and down the line actually make the trusses and other components from space-based materials, like the iron mining, asteroid folks that John was describing earlier, that would be a huge advantage to reducing the cost of building a large structure. But he's absolutely right. Unless you're able to make those in space, it's still a very delicate and costly operation to launch them from the ground.
Yeah. So. Very cool. Let's see, I'm going to pull up, what's this other one? Oh, well, I might as well pull this up. This is, of course, Starship.
Yes.
Which actually isn't supposed to be. It says Starship, but it really is just more of an Earth ship, because it travels around the Earth very quickly, up into low Earth orbit.
It can go further. I know it's designed really to cover the whole solar system eventually.
Okay.
Yeah, I mean, there are several uses, which is one of the really cool things, watching SpaceX's business plan develop. At first, it was called the Mars Colonial Transporter. I'm sorry, the image here isn't of the highest quality.
Oh, that's all right.
was just designed to take people to Mars to colonize the red planet. Elon Musk wants to build a Mars city there. And then they started thinking more about it, and they said, well, we could also use it to send people and equipment to the moon. It actually takes about the same amount of propellant to do that. And then they released some images showing Starship landing on Enceladus, one of the moons of Saturn, and other places in the outer solar system, which, that eventually is probably doable. You got to have a way to refuel it out there. So they're leaving a few things out. But then they came up with the idea of using it to send people around from one point on the Earth to another extremely rapidly, something called point-to-point transport. And I think that might have been what you were referring to, Adam.
Yeah, that's what I was talking about.
Yeah. I mean, that could revolutionize long-distance travel. Instead of spending 12 hours in a plane, you could spend 45 minutes, and if it only costs a couple $1,000s for a ticket, I think there's going to be a huge market for that. So all these things reinforce each other. If SpaceX winds up doing that as their main business, it still helps us, because it means that the cost of their Starship to bring things up to Earth orbit is also incredibly cheap. And that, again, is that foundational layer that the rest of the space industry gets built upon. And hopefully SpaceX will have a lot of competitors trying to do the same thing, which helps keep everyone honest. Yep.
And the price down.
Exactly.
We see SpaceX as actually needing space construction. You can only launch so many satellites, and with a craft that large, they could launch all of the satellites that were launched last year in a month. But space construction is different. There's going to be large-scale space construction projects going on, and they're just going to keep growing and growing. So when we talk about building things in space, it's the Starship that's going to be the workhorse at the start. Yeah. Blue Origin will come in later on with another large rocket, and there'll be other players too who are going to build large rockets, because there's a marketplace all of a sudden.
Exactly.
You can sell space on a large rocket because people are building in space. So it becomes self-reinforcing. This economy that you create creates an enormous economy down here. And America right now is in a really good position to take advantage of that. We can become something that we dreamed about when we were kids. A nation which is orienting itself towards the expansion of humankind throughout our solar system, because we have the rockets, we have the space construction companies, we have the mining operations. We can do all this. We have it on a small scale right now, but it's not going to be small in 10 years. It's going to be very large. It's going to be impressive what we're going to do in a short time.
Yeah. So if someone wanted to get into it, if someone wanted to become a space miner, become part of this, I just say a general movement towards moving into the space, environment, what would you suggest for someone? Obviously not everyone can become rocket scientists, or I'm sure there's a lot of Air Force pilots that then go on to be astronauts also.
Sure.
But what would you suggest for someone who really just wants to get out there? I mean,
I think there's room for more and more different skill sets. I've been to a number of space conferences over the last few years, and they're looking. Obviously, engineers are still a very important and I would say key technical qualification for a lot of the space business. But there's people who know finance, people who know business strategy and marketing, and then there's also the people who get creative and think of ways to capture the excitement of going to space and all the amazing things we're going to do. So, artists and musicians are going to be playing a role in this, and everything else in between. Our hotel is going to have hospitality services, world-class chefs, athletes, using the gymnasium facilities, and dazzling crowds both on the station and back on Earth. So I think there's room for somebody with just about any skill set, as long as they have the passion to be part of the vision.
Yeah, entertainment is going to be a huge part of what we're doing at Voyager Station, because we want the general public to come up there. So as Jeff said, we're going to have a lot of people who take care of the station, take care of the people being there. These aren't people with engineering degrees. These are people who focus on taking care of others and doing that job. So it's going to be a broad spectrum of people that we're going to need. But of course, when you're talking about building structures, yes, we need engineers. And we're going to need the pilots who've been flying aircraft to start piloting these craft, taking people around. One of the things we have to work on right away, you've probably seen images of it. It's called a pod. We showed some of those in the earlier video you had there, of moving structural components around to build larger structures. We're going to need pod drivers, people who can fly these things. We're going to need pilots who can use transfer craft, moving people between stations and so forth. So it's a lot that's going to happen at once when you build just one of these stations, one Voyager station. You start creating a community around it real quick.
Are you going to be able to see Voyager from Earth? Would you be able to see it?
Oh, yeah.
Yeah. Oh, yeah. Okay. How big is it compared to the International Space Station?
It's about
10 times the size?
4 times the diameter, because International Space Station is just over 100 meters for end to end. Is that right, John? And this one is, no, it's twice. This one is about 200 meters in diameter. So, yeah, it's definitely a bigger footprint.
So you'll definitely see it with the naked eye.
Yeah, if you know where to look. Mm-hmm.
So if I just want to, I don't want to go ahead. I just want to say real quick, if you need, someone to come play some music and float around, play a little guitar for people, you just hit me up. All right, I'm there.
We'll call you.
No time at all. I'll be there. I'll cut the show off. I don't care if you give me that call. I'm out.
Okay.
Awesome.
We are going to
put it in the air.
Who do what you do. We're going to need lots of different people. So that's one of the greatest opportunities of building big stations up there. You don't just need engineers and astronauts. You need people who just do lots of things in our society. So it's going to happen.
That's awesome.
Space journalists and space lawyers are two sort of newish professional titles that I've been seeing more and more. Yeah, we're going to need a whole army of you guys. Yep.
I like that. Space musician.
That's right.
I'm down. You know what? I'm going to spin this here UFO right here. This is for you too.
Yeah, one of the modules is designed just for musicians, and athletes.
Really?
Saying it's an auditorium, and we're looking forward to booking bands who want to play in orbit, because there's 2 auditoriums. So every night you're going to have these 2 bands or musicians or entertainers come on, and to entertain the people who come up there. And so you're going to see Sting in space, playing, on the moon. You're going to see Bruce Springsteen. You're going to see all these people up there. And it's a really important thing to have when you have large crowds of people, is entertainment.
Yeah.
So that's one of the reasons that we have the GA, the Gymnasium Auditorium. That's a module.
Well, did you hear that Tom Cruise is filming a movie next year?
We did.
In the International Space Station.
Yeah, we hope he eventually comes to the Voyager station, because he'll have a lot more options once he gets there.
I'm sure he will, right?
Yeah.
That's cool.
Yeah,
so
I was just going to...
go ahead. Finish up.
Well,
Jeff.
I was just going to say, I don't know if we mentioned to the listeners yet how many people our Voyager station would house. I mean...
No.
Okay, so we have a maximum capacity of around 400, including crew. And that is such a huge quantum leap from where we are now. The ISS usually accommodates 6 people. I think it has capacity maybe up to 8 or 9, at maximum. All of the other commercial stations that are being developed look a lot like ISS, and they're similar in size or even smaller. And they're not thinking dozens, let alone hundreds. But the whole key here is, we need the size partly to make the artificial gravity comfortable for people. But we also recognize that building at scale means that every person who goes up there is able to pay less per visit than if you're like one of 5 people. And as John was saying, you know, the more you have a community, the more appealing it is. And then we think it's a snowball effect. If there's only 5 people up there, you know, is that what's really the attraction? But if there's hundreds of people, including some world-class musicians, chefs, and other entertainers, you're much more likely to book a ticket.
I agree. It's very exciting. You think you'll have a skate ramp up there one day?
I don't see why not.
Yeah.
And imagine what you can do in 1/6 gravity, right?
Oh, I'm thinking about it.
Yeah.
I'm picturing it. So every time I talk about space, everyone always brings this up. All right. Every single time. I'm sure those who are watching are probably like, oh, great. Awesome. Because everyone's always picturing this. You know, we have the movie Elysium is, it's kind of like the halfway point between what you guys are actually trying to build and then this, because you can see the ground kind of, you know, scoops up, and I'm assuming it's a huge ring.
It is.
Just like Elysium, the movie. I mean, is this the future? Or is this going to be a reality?
I believe it will one day.
This is a large-scale structure, what they call a settlement. It's beyond the idea of a spaceport even. Spaceports are going to have continuous volumes like this going all the way around. But when you get really big, that falls into the class of a settlement. And they could house, well, as many people as you want, if you just build them big enough.
Yeah.
This is a follow-on to our space construction machine technology. When we talk about the star making trusses, you then step up to the G cell, which is making larger segments. In that same video that you saw earlier, we have another one that rolls out next to it called the double Y, which makes wider segments. That is exactly what you're going to see. You're going to see a continuation of this expanding scale of these space construction machines, building ever larger trusses and structural components all at once very fast. That's how something like this is going to become reality.
Yeah, I should point out that image actually, so that's called an O'Neill cylinder after Gerard O'Neill, who kind of popularized the idea back in the 70s. But this is a modern rendition of it, actually put out by Blue Origin last year. So Jeff Bezos, who in addition to running Amazon, also has a space company, not everyone might know that, called Blue Origin. And while they're focused on sending tourists up on a very small rocket for a suborbital flight right now, they do have some large ambitions. And this is what he trotted out as part of his big vision with the idea of millions of people living and working in space. So
wow,
glad you brought that in.
Yeah, that's exciting because, you know, he's one of the richest men on the planet, I think, right? I don't know if he is.
He can't do it. He is currently the richest person on the planet.
Oh, he is? Okay. I
yeah.
thought so. I honestly, I'm happy to know that that's where his mind's at. You know, obviously, I would like to preserve Earth and make sure that we're not over consuming. So, you know, Amazon makes it rather easy for people to do that. But, you know, as long as we're moving towards a better future together, I think, you know, we're on the right path. So this is really cool.
Yeah, I think that is a step along the way. Being able to put those things, I just want to add, you know, that being able to operate something of that size almost requires that you can maintain a stable ecosystem in space with limited materials and energy budgets. And, you know, you don't have everything overgrowing with algae or fruit flies or anything like that. And so if we figure out how to do that up there, I think there's going to have to be benefits down on the planet again. And I think that space can help save the Earth.
Yeah. Well, we basically just have to make an ecosystem, and we got to figure out how to understand the balance of the ecosystem that we've got on this Earth, which I feel is a whole other conversation.
Oh, yes.
But being in space, it's even more important because if it fails, what are you going to do? You know, you can't just be like, all right, well, I'll just go back down to Earth real quick. And, you know, it doesn't really work that way. You got to make sure that everything is so, you know, taken care of. And,
yeah, it's step by step. What you're showing is probably not something we'll build for at least 50 years, maybe, you know, even 100 years. I'd like to think it's sooner than later.
Yeah, 50 years actually caught me off guard. I would have expected, 200 years, because you think about the size of what this. Let me just bring this back up so people can see what I'm talking about.
I mean,
about the size of that.
I'm an optimist. Of course, 50 years does seem very ambitious. I wanted to put it out there because I think if we really put our minds to it and we made this one of our highest priorities, we might be able to maybe not this size in 50 years, but certainly something that is a self-sustaining ecosystem. And then we build out from there. But you're right. I just want to say, we got to take care of the planet too. This is not an escapist fantasy. This is like a both and sort of enterprise. We're not doing this in order to leave all of our pollution alone. It's actually to try to make the Earth a better place to live in. Yeah,
Earth is a great spaceship. We don't want to mess it up. It's the only one that we happen to have right now.
Right.
That's true.
Take care of it.
I think that's what people like to knock Bezos for, because they're like, oh, he's just becoming rich and then, buying his way off to the planet. And it's like, how do you know that? I have yet to see anything that shows that to me. So I don't know if that's true. I think it's ridiculous.
Well, this one quote I'm about to give you will probably lay to rest any suspicions people have about where his intentions are. He says, I can't give an exact quote, but basically his vision is to move all heavy industry off of Earth and into space.
Yes.
So that we can have a clean planet to live on again.
Yes.
That sounds awesome.
And Arthur C. Clarke's dream too. He's paralleling with Clarke. And space construction can help him make that happen. We're ready to start building all kinds of structures in space. It's the first step. And that image you just showed there a minute ago, Adam, that was put up in newspapers while he was advertising for someone to help start making large structures in space. He wants to hire someone doing the kind of stuff that we're doing right now.
Wow.
Yes.
So he's planning it. It's on his radar. I mean, he started in a little tiny office, just by himself, and he made his vision come true. You can't knock him for that. He definitely is a visionary and made it happen for himself. So that's really exciting. So how do people get a hold of your if people want to see and help this construction company come to fruition, because it's happening, right?
Yeah, we have websites that people can go to. Orbitalassembly.com shows, as you pointed out when you went there, all of our space construction tools and machines that we're working on right now, and a few that we haven't got on the website. But also Gateway Foundation is another one that you can go. They're all kind of linked together. And there's another website, which is Voyager Station.
Voyager Station.
Yeah. That you can go to get really good images of Voyager Station, which is one of our early ambitions. After we build the gravity ring. So you get to one of those stations, you can get to them all. And very impressive. And we're selling stock soon also. That's another thing that's on our agenda coming up.
Oh.
Yes.
That's interesting. I'm interested in that. I truly believe that is the future. We can't have these massive structures in space, these epic advancements in solar array technology beaming us down microwaved energy, which sounds awesome, without being able to build it. So if you guys are creating a company and you can get in stocks, I mean, that sounds really interesting. I'm definitely looking into that.
Thank you. Cool. Well, stay tuned. We'll have more information soon.
It's coming soon.
What was that? What was the third website? You said Orbital Assembly, Voyager Station, and then what was the third one? I just want to bring that up for everyone to see. Gateway Spaceport.
Yeah, gatewayspaceport.com. That's our biggest vision of building spaceports. We want to create that age of spaceports where there are rings of different space ports around the Earth, and regular flights going up every day and so forth. This is actually not that far away in the scale of things. This station, which you're looking at right now, which is a different station. This is Voyager.
Oh, that's not Voyager?
This is Voyager.
Yeah. Oh, this is the port. Okay.
Right.
Yeah.
It's much bigger.
It's showing them both. I see. It's switching between the two.
Yeah, and we have some side-by-side images on the website for people to know to see the distinct differences in size. But this is one that we're talking about has continuous volumes inside without the module problem. Voyager Station, these modules here, you have to walk between modules to go to the restaurant or to go to the gymnasium, that kind of thing.
Yeah, but it's still a very large structure space inside. I mean, it's going to feel very ample.
Yes,
it's amazing. This is the future right here. I'm looking at the future of humanity, the space, the final frontier. Like we talked about it. We're all Trekkies here. I know you guys like Trek. And we were actually having a discussion right before we went on live whether or not Star Wars versus Star Trek. And sorry to burst both of your bubbles. I'm just going to announce it to the world. We're all Trekkies. All right, all three of us.
Yes,
just really like the Star Trek universe. We got nothing against Star Wars. All right, don't get all
also
upset
very
with
cool. Yeah,
Star Wars is cool.
Yeah,
but we're Trekkies.
Yes, we are.
Well, Jeff, you kind of like them both.
Yeah, I kind of straddle the line. I grew up with Star Wars, but Star Trek definitely appeals to my higher mind. So,
right. So, man, this is really cool. Before we get into super chats, I just want to say to both of you, thank you very much for joining me today. I'm really excited about every single thing we've talked about, and to see you both be successful in creating this, because this is incredible and this is the future, and I truly believe we're moving there.
Well, thank you for having us, Adam. It's been a pleasure being here.
Yeah, absolutely.
Yeah, it's been great.
All right, so we don't have too much time left. Well, we got about a half hour, just over. What time is it now? 7:35. All right, so we got about 20 minutes to just answer some questions that some people might have had. We got Mark Robershaw says electromagnetic accelerator gates for space travel. Would that work? Does that work?
I think he means. Can I take this one, John?
Sure, you bet.
Yeah, I think he means something that's akin to what's called a mass driver. So essentially, it's using electromagnetic coils to accelerate a mass along a track, and you can get up to very high speeds very quickly. Now you can go way faster than a human being can take, like thousands of Gs. But it's fine if you're like accelerating chunks of metal, maybe to get to one of our shipyards one day and coming in from the asteroid belt. So that's definitely possible. And it would allow you to not have to use propellant, which is actually a pretty precious commodity and takes up a lot of mass and space. So it's definitely possible. For people, you kind of have to be careful because the human body can't take more than about a couple of Gs on a long-term basis. 1 G or below is better. So essentially, if you're going to use that instead of a rocket from the ground, good luck. But if you're already in space, you could probably imagine a track a few kilometers long that could slowly accelerate a spacecraft to the required speeds.
But then, of course, you have to worry about slowly bringing it down to.
Well, yeah, you'd need a sister station on the other end to kind of bring it in for landing. That's right.
But I was actually thinking about this, just to bring it back to the gravity ring that you guys were talking about. How would this be? Would it have rockets that would kind of start the motion? Would it have electromagnetics kind of a thing going on?
Yes, in 4 places around the rim, we're going to have spin up, spin down motors, which are also combined ACS, which are attitude control. So it is a spacecraft in a sense, but there's no pressurized volumes here. It's just a research tool so that we can have a person basically step on board and feel artificial gravity from space for the first time ever. So it's simple, but it's very, very important. So this is an important tool here is what it really is.
So it's a tool / science experiment to try to understand artificial gravity in space.
Exactly. Yeah. Also, we're doing something else there too. One of our space construction machines, the STAR, the prototype, is going to be tested out building this truss. Now, you've seen the G-cell, which is another rendition of it, doing that. It can build this truss very fast. We suspect it could build the whole thing in a day. So. Yeah, that's the state of the art of space construction is building things quickly using automated assembly like we have on the STAR.
Very cool. All right. Robert Weil says, have a blessed night and life doing what you love, and thanks for all you do for us. Try True North snacks. I'm a meat eater, but they make vegan snacks. Well, thank you, Robert. I'll check those out. Reaper says, when do we get a Death Star? Who wants to take that one?
Well, I'm a Star Wars fan. I don't know. Should I?
Yeah, go ahead, Jeff.
Go for it, Jeff.
Death Star. Well, well, first of all, okay, so Death Star. If we're just talking about building something the size of the Death Star, I would say that those large artificial habitats that Jeff Bezos and others want to build actually would qualify, at least in terms of size. Yeah, but of course, the Death Star. One of the things I don't like about Star Wars is they made up a lot of physics, right? I mean, Star Trek too, beaming, I'm not sure, but a lot of the things.
One day, we could have it.
You asked about gravity plates, so Star Wars also has implicit gravity plates. There's no rotation that causes people to stay on the ground. It's just they turn it on or off.
Yeah.
So a Death Star, doesn't really physical, but if it was spinning, then you have what's called a Bernal sphere, which would allow you to walk around on the inside like normal Earth. And then as far as having a giant killer weapon, oh, sorry, go ahead.
No, that's fine. You go.
The giant killer weapon would be sort of our space solar power system, right? Beaming a death ray of microwaves to wherever you want.
Yeah, that's why I brought this back up, because I saw a bunch of people in chat when we were talking about this. They were like, it's a space weapon. It's because it
This is
kind of looks
actually a
like
real concern. I mean, there is a concern that if you build one of
True.
these things, could it be weaponized? And so part of the designs in the community, the small community of people thinking about this, is to ensure that it cannot be focused beyond a certain point just by the physics of it. So that the worst that you can do is make people slightly warm on the ground, but it won't fry them. So that's
if
important.
nothing goes wrong, and the checks and balances stay in place and aren't thrown off and out of whack.
Yes. Well, believe me, this is probably going to be one of the biggest sticking points for this technology to ensure safety, and not just we promise not to use it for bad things.
and that doesn't always work, as we know.
Doesn't go well sometimes.
All right, Mark Robershaw says Straya. What does that mean? I don't know what that means. Mark says, would you hold the world hostage with asteroids? No, of course not. Of course we wouldn't.
Kind to expand into our solar system. You don't want to keep people oppressed and down here.
Yeah, right? Come on.
Our goal is not to, I think we should go after all those rogue asteroids and turn them into space stations. Let's bend them to our will.
Yes.
Yeah. No, seriously, they are hazards right now, but they're actually like free material for the offering if we can only get to them, and they're closer than the asteroid belt. So
that's a really good point. We could mine everything there. We just, you say you've got one of your machines, you're building devices, just drop it on there, and it both excavates, shifts the material into something to create, and build all right, and send it around, and it's just gonna go around its orbit, and in a few years, you populate it, and then all of a sudden you've got a rotating asteroid that just is flying around. That's
you just articulated part of my long-term vision. I mean, it's not just mine. Many people in the community imagine that. Yep.
Very cool. I never thought about that, but that makes a lot of sense.
Awesome. Yeah, turn a threat into an opportunity.
Yeah,
I like it. And you could steer it a little bit, with different things if you need to. If you see the trajectory is heading towards Earth, you could be like, all right, just hit this button and boop. Now it's, out of the way.
Most asteroids probably have enough water or other substances that you can use as propellant that would allow it to be sort of nudged to a safer orbit. And there's other things you could do too. You could just throw like big chunks of rock out the back and sort of push it that way too. So yeah, it's quite possible.
You make it sound quite easy. Yeah, just toss some toss some rocks out the back. change the whole trajectory.
In the near future, when asteroid hunters are going to look at every rock that we're afraid of existential reasons of hitting Earth as a sheep, like a wolf looking at a sheep. It's not going to be a threat anymore. It's going to be the next meal, and they're going to be looking for these. The closer ones, the better. The bigger, the better. They'll go out and fetch them. Yeah.
Monetary value of those too.
There you go.
As long as space construction is there to buy what they have to sell, it will happen.
Yep, and they'll be there. It's only going to get better.
Yes.
Mark again says, did you test this in the Kerbal space program?
No, we did not.
Not yet.
Okay, not yet. Mark again says, humans will evolve in space to suit space. I believe that. I believe that.
Yeah,
it might take a while.
It might take a while. I mean, we've already talked about altering our DNA in order to make ourselves like less susceptible to space sickness, maybe the effects of lunar gravity or zero gravity. I mean, who knows what the long-term effects are going to be? The first thing is to find out if humans are actually able to function safely for long periods of time in less than 1G. We know we do pretty well in 1G, right?
Yeah.
Other things aside, but as John was saying earlier, is half a G enough? A quarter, an eighth, 5%? At one point, things start to break down. But if we find that we really like lunar G and people start having children, which is a big, wild card, maybe.
That's the big number. That's the gestation number. Yeah. What is the gravity that's required for our species to continue? Because what if we couldn't have gestation on lunar gravity? that means a lunar base is going to have a hard time existing. I mean, people have to come back home to have children and then go back out there. What if Mars wasn't enough for gravity? I got a feeling it's going to be fine, but I don't know. Nobody knows, and we will know. We build stations like Voyager, and we can start doing research in large populations of people.
Right.
Wow, I didn't even think about that.
Yeah,
but we're gonna know. I mean, within 10, 15 years, this is happening. We're doing this research. We're really trying to move towards, being in space.
Yes. We're long overdue for this research. Actually, we probably should have been pursuing this back right after we landed on the moon, but we had other priorities.
Yeah.
Well, and it was expensive, right? And then the public didn't like the fact that it was risky. There was deaths right away off the bat. I think it was Apollo 3. I don't remember exactly which one, where the 3 astronauts died, and the public were like, "Whoa,
we almost lost
like this." Yep, exactly. This one is Mark Robershaw again says, "Bones are primitive tech anyways, time to improve." That's probably one of the biggest things that are going to be affected is our bones. Right?
He sounds like a transhumanist. Yeah, looking beyond bones. I'm not sure about that. I kind of like my bones, but
yeah. Well, I do too. Do you know The Expanse? The show The Expanse?
Sure.
Yeah, I've heard of it.
So the Belters are super tall, and their bones are really long and lanky and brittle because they just aren't ever in gravity.
Yeah,
it's interesting.
I think
Josh,
go ahead. I was just going to say, you brought up The Expanse. So I mean, The Expanse is interesting. They have some rotating space stations, right? Like the one out, I think it's called Tycho Station.
Tycho Station, yeah.
Right, but strangely enough, like not everybody's on that station having like healthy bones, in an Earth normal gravity or something close to it. Instead, they're like floating out. I think there's a habitat on Ceres, and Ceres is the largest object in the asteroid belt, but I think its gravity is something like 3% of Earth's. So it's almost weightless. And it's like, anyway, creative license, right? But we should be people in rotating stations, but that's our bias, I guess.
Yeah, I'm sure a lot of those kind of space shows, your mind can't not analyze it and be like, that's not accurate. That's not how it would be.
Yeah, I guilty as charged.
Josh and Jesus says, "Did you get my email, bro? I'm sorry I didn't check it, but I will check it." Mark Robershaw again says, "Bro can train like Goku and Vegeta." Right on, yeah, altering the gravity. Mark again says, "Athletes training in 2G gravity, nice." Yeah, maybe could you essentially? I know you said spinning it faster would work, but also if you went even wider with it and you could just continue the same amount of speed and it would just increase the gravity.
You could easily have multiple levels, and you could even drop like a little cable down way beyond the normal ring that could be at 2 gravities if somebody wanted to have an intense weight training program.
Right on. Mark again says, "Manipulate the Higgs boson field for gravity control." See, I wanted to talk about that a little bit more. You got to think about, look at like technology over the past 100 years. It's just this spike, and we're getting better and better at knowing everything. I mean, not every one person knows everything, but we have such knowledge, like, on my phone right here. Like I have nearly everything on this phone. Now, there's going to be a child one day that goes, I want to understand this specific thing and delve into that and make it their life and suddenly crack the code of understanding gravity.
Who's to stop them? No, anybody with a great idea should go for it. But that's way above my pay grade.
I think it's going to happen. I believe it. I'm just putting it out there, just like you said. You're an optimistic person. I like that about you, and I think that's the key. You just got to be optimistic and believe, and be put it out there. Put the good energy in there. Mark says that's Halo plagiarism, bro. I don't know what you're talking about, but there's about 40 minutes ago, whatever we were talking about. Yeah, that's all good. Mark again says, harvest those asteroids. Yes, we will.
It will.
As you said. It's their blood in the water, essentially.
Yes.
Devin Stark says, ask him about the O'Neill cylinder ships and using those stations as space anchors for space elevators.
Ah, Now there's
we
an
talked about the O'Neill cylinder ships. We talked about that a little bit because this was before we actually talked about it. But what about using them as space anchors for space elevators?
Okay, so
Interesting.
part of a space elevator idea, and I think he means, well, I guess it could be a lunar or an Earth elevator, but you have what's called an anchor, which is a counterweight that sits way out beyond the gravitational balance point, which is essentially like the spaceport at the very end of the line. And what's cool about being there is there's actually quite a lot of outward force. And so if you let go a spacecraft, a person, I guess, but you would want to be on a spacecraft because you can actually take off to interplanetary speeds and reach Mars or other planets in a few months. So absolutely, you'd want to have something rotating in order to provide the right level of gravity. But essentially, so the Earth is above, and you have this very long cable down. At the very bottom, you're basically like hanging off of like the bottom of a floating structure. So there would be some outward gravity there.
I was looking. I actually have a picture that represents exactly what you were just trying to explain, and I couldn't find it. But thanks for
for another
that.
show, maybe.
Yeah. B-Ball for Life says, I'm sorry if this is off topic, but can you believe that there are people who believe space is fake and the Earth is flat? Can you guys believe that? Can you?
It's hard to believe.
It is hard to believe.
It is hard to believe that there's people that don't believe space is real. Well, what do you think it is?
Well, they can buy a ticket and go up into space in a few years' time, and then they can make their own.
You know what? We need that. We need to, blow the minds out of these people.
Lay
Because
it
they
to
need
rest,
to.
people.
Yes,
But I
stop it.
Website who say that kind of thing. I tell them, people are saying, why don't you send these flat earthers into space? And I would say, I would much rather send you into space.
Right.
Because why waste your time just to convince this person when there are people who are already convinced and ready to go? That's the kind of person you want to send out there.
Yeah. Exactly. 100% agree. Mark Robershaw says void shields. I think that was basically the magnetosphere conversation, maybe, because that's kind of, it's essentially what it is.
This could be very important technology down the line for human habitation. So watch that space. I think we're going to be seeing more development in that area.
Well, it's really intriguing to me. Brian says, just finished your drawing. Check out my YouTube channel. Okay, I'll check it out, Brian. Thank you. Do me a favor, email me at adamcastirl@gmail.com so I can check it out. Thank you. Let's see. Chioma says, where will the materials come from for the space structures? Resources on Earth are limited. Are we going to resource from space or hollow out Earth? We can't have Earth architecture compete with space architecture for limited materials. Thanks. It's a good question.
There's probably no limit of materials that we could draw from our solar system for building these things. But for the next 100, maybe 200 years, there's plenty of materials right here on Earth that we can go through. The problem is really economics. After maybe 20 years, maybe even 30 years, we're going to have those resources coming in from space, and no one's going to think about lifting something out of this big gravity well that we live in. It's going to come down, from the moon, like Jeff was saying earlier, or it could come from the belt. It could come from a lot of places. So it's just a short time gap where we need to draw from Earth our resources.
Yeah, I agree.
Basically, so you want to bring up the very lightweight but high value items like electronics, robotics, exotic materials, chemicals that are very difficult to make, but you need it to do some kind of purification process. All that stuff will continue to come from Earth, but the heavy, simple, dumb stuff like making concrete and steel and glass, we can make all that from space resources, like John was saying, and we will.
Cool. Thank you for that. Mark Robershaw says, space. I'm not going to read that, Mark. Come on. It's a little, it's kinky. That's what he finishes up by saying kinky. Right. Okay. Mark again says, no, that's a photo of Death Star. Don't even deny it. I knew people were talking about that. The picture that I brought up.
Space solar power system. No, it really is
a
friendly solar powered electricity system.
Just solar power. All right. Mark Robershaw again says the chances of anything coming from Mars was 1,000,000 to 1, he said. All right. Well, we're definitely going there, though. That's true. Truck Morris says, "Isn't this how Gundam started? So corporate space war. I'm in." I've never seen Gundam actually, but have you guys watched Gundam?
I haven't.
That's okay. So none of us have. But sorry, everybody. I know there's a lot of Gundam fans because people have brought up Gundam many times because it is set in the future and they do live in these O'Neill cylinders, and it's kind of cool. As far as I've learned from people talking about it, Mark says, "I will build a Penrose spear and end the universe." Mark, why would you want to go and do that? Huh? Why would you want to do that, Mark? Come on. And then DJ Ronnie says, say it again.
I said, I don't even want to know what a Penrose sphere is, but it sounds dangerous.
Yeah, I don't know what it is either, and I think I'm good. DJ Ronnie says, on Babylon 5, CNC, command and control, is located closer to the center of the spin. Are Earth Alliance officers who spend more time in that area at higher risk of osteoporosis?
Probably.
Good question.
For a long time, yeah, they would be. But the thing is, station personnel, even if they're running the station from the center, they're going to be moving to the outer rim for sleeping, for meals, for exercise. So, and it's encouraging early reports that we're getting from people using centrifuges down on Earth that just a few hours sometimes of gravity can really help you out a lot. So,
get your blood moving.
Yeah, but that's an energy field. So who knows what it's going to be when you're continuously in a low gravity field? That's a little different. That's something we need to add on.
I mean, one thing that we didn't touch on earlier, and I know we just have a few minutes left, is this idea of working in zero gravity, but then living and sleeping in some gravity field. That might be important depending on the kind of work. In addition to sort of the high tech stuff, growing perfect crystals or special kinds of fiber optics, for instance, is a good example. Yep, something that's happening now. We might find that it's just much more convenient to move heavy masses around without the force of gravity. And so there could be a very important and large space industry that happens in zero G. And then you kind of spin things as needed to sort of create, differentials of different kinds for suction or for gravity fed separation. But I think that those people would still have to take time off in a gravity field.
Yeah.
Well, thank you guys for joining me. Seriously, this has been, I love talking about space. I love talking about the future of humanity because we're definitely moving towards, being a spacefaring society. Why don't you, I'll give you both a chance to just tell people how to follow you, how to, check out your work if they'd like to. Jeff, I'll give it to you first.
Sure. Well, I don't tweet very much, but you can follow me at Energy Geek, which I've had for several years, and I occasionally post interesting things there. We can get in touch via the Orbital Assembly website, all of us.
Cool. And then, John, over to you.
Yeah, you can reach us on gatewayspaceport.com. You can leave comments there. You can leave comments under our videos on YouTube also, which I encourage you to take a look at because they're chock full of information about how space construction is going to happen and what kind of machines and what kind of people we're going to need too. So that's a good place, a good resource to start right there. And the Orbital Assembly, our main website for construction, is a good place to leave comments too. So I look forward to hearing from you. Thank you.
Excellent. Well, John, Jeff, thank you very much. Oh, well, we got one more super chat. Let me just GG, thank you for that super chat. It says, what are the protections against solar flares, solar storms, and such? Well, we kind of did go over that, right? The concrete barrier, the ice barrier, and then, of course, the artificial magnetosphere that they don't have per se at the moment, but they are definitely working towards, building an artificial magnetosphere, right?
We have a lot of water on the station. So in the near term, there would be sufficient quantities that people would be able to, hide in a storm shelter given the amount of water that would be on the station. Interesting.
Well, thank you very much for joining me, everybody. Thanks for showing up on this conversation about space. I know it's not my usual show. Usually I do segments about what's going on, and but every so often I have guests that come by and talk about really fun, exciting stuff, especially space. I'm a sucker for talking about space. So thank you both for joining me, and you all have a wonderful night. You can catch me later on my Twitch channel. Usually I go live around 10 p.m. And if not, I will see you tomorrow at 6:30 here on Atomcast IRL. Thank you very much.
Thank you, Adam.